welcome back to my channel. After a short break, we're back with an exciting project. Let's get started. Today, we're introducing a basic prototype of a touchscreen display-based circuit to control a servo motor. This project features 3 modes: touch control, manual control, and swing mode. Touchscreen displays are everywhere, like in ATMs, elevators, and smart home systems. In this project, we use a similar concept to control a servo motor in a versatile and interactive way. To bring this project to life, I've connected the 2.8-inch ILI 9341 touchscreen display and a rotary encoder to the Arduino Uno, which together control the servo motor. The touchscreen serves as the interactive interface, while the rotary encoder adds precision in manual mode. For those who want to try this project, I've included the connection diagram and Arduino code in the video description. You can find them easily and follow along to create your own version of this versatile system. Coming to the coding section, the entire code is written using an AI interface and is fully commented to help you easily understand and customize it as per your preference. In brief, the code initializes the touchscreen display, Adafruit ILI 9341, rotary encoder, and servo motor, enabling control through 3 modes: touch control, manual control, and swing mode. The UI is designed for smooth navigation, allowing you to switch between modes effortlessly. Each mode is programmed with unique functionality to demonstrate the versatility of servo control. Let's explore how it all works. In touch control mode, we can easily adjust the servo angle by interacting with the slider displayed on the touchscreen. The angle updates in real time as we move the slider, and the current servo angle is displayed on the screen. This makes it simple to control and precisely monitor the servo's position, adding an interactive and intuitive element to the project. In manual control mode, we can precisely control the servo angle by turning the rotary encoder. Each increment of the encoder provides fine, gradual adjustments to the servo's position, giving us excellent control over the movement. This mode is particularly useful when precise angle adjustments are needed, such as in robotics, camera positioning, or other applications where accuracy is critical. By rotating the encoder, we can easily navigate through different angles, ensuring smooth and accurate control of the servo motor, making it ideal for tasks that require meticulous movement control. In swing mode, the servo motor continuously sweeps back and forth between 0 and 180 degrees, creating a swinging or oscillating motion. The speed of this movement can be easily customized by adjusting the swing delay in the code. This delay controls how fast the servo moves, with a smaller delay resulting in a quicker swing and a larger delay slowing it down. By using the touchscreen slider, you can modify this delay in real time, offering full control over the swing speed. This feature is particularly useful for applications like automated doors, mechanical arms, or any project where dynamic and adjustable motion is required. Thank you for watching. I hope you enjoyed the project. If you liked the video, please hit the like button, subscribe, and turn on notifications for more updates. Drop any questions or suggestions in the comments, and I'll be happy to help. See you in the next video.